Hi all. Now let's see the last strategy for handling deadlock problem. It is deadlock detection and recovery. Deadlock detection and recovery is the most usable, or it is the most practical, which are used in various operating systems. So earlier we use deadlock ignorance approach, but nowadays we are using deadlock detection and recovery method. Okay, so in deadlock detection and recovery, we have two phases. One is the detecting deadlock, and the other one is recovering from deadlock. So the first is how we detect the deadlock. So detect deadlock. So if in the previous two videos, while I was discussing the resource allocation graph, so based on the resource allocation graph, we can easily detect the deadlock problem. So detecting deadlock can be classified into two categories. One is if the graph is single instance, and other one is if the graph is multi-instance. Okay, in case of single instance, cycle is necessary. If there is any cycle present in the resource allocation graph, then definitely this particular graph is causing a deadlock problem, or this particular graph number of processes or resources are present in deadlock situation. So here we can say that cycle is used to find whether a deadlock is present or not in single instance resource graph. And what about multi-instance resource graph? Here cycle is not necessary, but not a sufficient condition. So definitely cycle method is not work here. We use some other approach. So if you remember, while discussing deadlock avoidance strategy, I discussed Banker's algorithm. So here in multi-instance resource graph, I will use Banker's algorithm to detect a deadlock problem. So Banker's algorithm is used to detect deadlock in multi-instance resource graph. So this is one phase of deadlock detection and recovery. Now the next phase is recovery method. How we recover from the deadlock problem. So here also it is classified into two categories. If the deadlock problem is occurred due to the resource, then we can handle it separately. And if the deadlock problem is occurred due to process, we can handle it separately. So based on resource, we have to handle differently, and based on process, we have to handle the deadlock differently. In resource, we use two approach. One approach is preempt the resource. Preempt, you already know what is the meaning of preemption. Preemption means forcefully stop the resource and give it to another process and see whether giving resource to other process will cause deadlock or not. If it does not cause deadlock, then we will go with that step. And the next approach is rollback. Rollback means if, let's say, we are after allocating some resource to the process, we are currently in unsafe state, then we move back to the previous state which is safe, and then we try another thing. We try allocating resource to different process and see what happens. So rollback means going back to the previous state, which is safe state. And in case of process, here also we use two different strategy. One is you just kill one process and check whether it is safe or not. Means whether it will lead up to a problem of free deadlock problem. Okay, so killing one process is, if sufficient, then go with that. If after killing one process is not sufficient, then the last option is kill all process. Kill all process. Kill all process means the process which are present in either ready state or run state or waiting state, whatever be, you just kill all the process and restart again. Okay, so these are the two approaches which is used in process, and these are the two approaches which are used in resource to recover from deadlock problem. Okay, so deadlock detection in single instance cycle is necessary and sufficient condition, and in case of multi instance we use Banker's algorithm to detect deadlock, while recovery resource is handled separately and process is handled separately. So you just note down these concepts in your notebook and try to remember. Okay, so that's all about the deadlock concept. In the next video we will see memory management concept.